The first part, as usual, I would emphasize on the concepts. You should have a solid root level understanding about where it has stemmed up and how it is going to address the higher problems which you cannot deal with traditional systems. That is the big data. And in the same class, I would ask you to set up your environment, because this is not just theory. Theory comprises about 40% in the classes. So most of the time you have to do a good amount of homework. So basically I would recommend Hortonworks Sandbox. It's around 4 GB. You have downloaded it for you. I'll send all the links to you, how to set up the environment, how to establish. If you're not familiar, I'll send the whole thing. Also, I'll send you the Eclipse Studio. Even though you may not be interested in writing Java code, but I'll show the flavor. If at all you have to work on some Java side of thing, you shouldn't be like unfamiliar with that. So I will help you in setting up the Java environment where you can run programs, develop programs to work on Hadoop at a core level. So that way I'll help you in this. Hadoop, I choose Hortonworks because there are 3 competitors in this area. One is Cloudera, second is Mapr, third is Hortonworks. But I choose Hortonworks. The reason is that this comes with a lot of tutorials and many realistic problems. So for a layman, this is like heaven. Whereas Cloudera, if you should be a little geek to understand this, they go at a higher level. So for beginning, you'll have some trouble to understand that. So there will be some learning curve in that. Mapr is a different ball game. They're focused on the enterprise level offering, so they are not abundant with examples. Not that they're not bad. They are bad, but they are not abundant with tutorials. But Hortonworks providing a very wide variety of tutorials. Even after the class also, you can still pursue the tutorials. There are multiple levels of tutorials you have: beginners, medium, intermediate, and advanced. So even after this classes, one month like that, you can pursue the tutorials and keep coming to tutorials and enrich your learning. Right? That is about it. So this is the VM. This takes around 4 GB in your PC. If you are using Mac or Windows 7, you can run this VM. This gives you, this is a Linux PC, Linux virtual machine running in your Windows 7. So this gives all the flavors of Hadoop, all the tutorials we will be discussing about it, and also the Hortonworks tutorial. Not the one I teach, not only the one I teach, the Hortonworks tutorials also you can run on this VM directly without any much hassle about focusing on the availability of libraries, the paths, so all are taken care in this VM. So good to understand the concepts. Then you can struggle even once you want to go for advanced learning. Then there are different things. This may not be helping you if you are taking realistic problems. No, if you want to process 1 terabyte data with this VM, you can't do it. But for learning sake, this is pretty much sufficient. You get all the essence of the learning here. Okay, so that is the introduction and the setting up the environment for you. So from day 2 we will start some hands-on, or day 3 if you take some time in setting up the environment. Let us take day 3 like that. We will start this hands-on like that. And also, before I move on to the actual discussions, I would leave you some of the use cases where Hadoop is popular. And not that Hadoop is a panacea for everything, but there are good amount of use cases at high level. Not a integrity of things. At high level, we can discuss about ABC like that. Use cases are there where Hadoop is very good fit, and the use cases can be subdivided into many categories. But we will be looking at very high level categories of use cases. Then, now the discussion will start on the Hadoop internal things. What are the basic constituents of Hadoop? How it is positioned? How it is composed? And how it is solving the bigger problems. The part 2. This is purely on the Hadoop area. Hadoop comprises about the file system and the computation areas. We will discuss about it. In the part two, we will cover the Hadoop discussion. But Hadoop is just a platform. If you have heard about Java or .NET or any other programming languages, the basic thing you see, imagine a case like Java. You often come across a tool that is built on Java, or you often come across a framework that is built on .NET. What does it mean? So Java and .NET, they are not just programming languages or frameworks. They are more like platforms. You can develop applications around that platform, like on Java and .NET. Similarly, the Hadoop, it is not just a mere programming area. It is a more of a platform. It can allow you to develop enriched programs or applications on top of this core Hadoop. So that is what we call ecosystems, means they work together. They can't work independently. Like if you have Android phone, the app is called part of Android ecosystem. That means that app cannot work in anywhere else. It only works in Android. So the app comes from ecosystem background. Similarly, Hadoop, the various tools and technologies work in Hadoop. They are like ecosystem things. They work in conjunction or in collaboration. They can't work independently like that. So that we discussed it. There are a bunch of tools, right? From Apache Hive is most popular. This is in the popularity index. Hive is the most popular one. This is most will excite you, the warehousing people, the database people. You see no difference between your SQL or Oracle interface. You write a query, you get an answer. Everything you can do. All ANSI, SQL, or SQL standards it follows. You'll have tables, joins, indexes, views, everything you'll have. You can even write a scripting model also if you would like to. Pig is for the scripting world. If you are from Unix scripting or DOS scripting or any other PL SQL scripting, where predominantly you do some workflow, you develop some workflow against some data systems or repositories. Pig is for you. It is like more of ETL thing. You can load data, extract it, and transform it. And then HBase, it comes from a new world. It is a paradigm shift in the database area. It comes from the NoSQL world. So there is very good advantages, compared to the relational databases. It has own flavor, and coming to the big data kind of use cases, we should need a different world to address the problems. We'll touch upon this. So the HBase basically, it is for just to leave you with one insight here is that imagine if you have a database of 1 petabyte, means 100 terabytes, 1000 terabytes, right? 1000 terabytes. First of all, I don't think that database exists. But if you have 1000 terabytes of data, and there is a big table, let's say table for a world population of 7 billion people. Imagine that scenario. If you write a query about, get me all the Indians spread across world who aged between certain this and that, who have this kind of qualification, put all the conditions. Imagine if you have such fictitious table, that query has to traverse all the 1000 terabytes of data. Imagine that case. It would never come back. The reason is that, not that technology is inefficient in that, but the kind of processing it has to do, it's a mammoth thing. So much of data, the indexing itself takes longer time, so you can't achieve it. That's not use case for it. But had it been a case that 7 billion people's data of the 1000 terabytes implemented a NoSQL paradigm, that is pretty quick. You get a response in milliseconds. So how it has happened, we'll discuss that. So HBase is the tool that is for giving you a flavor of database kind of model on a huge data sets, where the data set is mostly unstructured or semi-structured. and that gives all the flexibility of schemaless databases. Imagine you have 100 terabytes of data and you have to update a new column or add a new column or delete a new column, delete an old column. I think you would have seen the pain in managing database, maintaining database, right? You have to take a lot of downtime, the amount of backups you have to take, so much of overhead involved in that. But HBase, nothing is required, no backups, no maintenance, on the fly, it can accommodate any changes. So that is because it comes from NoSQL background. So we'll discuss about HBase. And finally, I'm saying finally is that these are the 4 popular things. Rest of all, like they are need basis, you can get into it. Scoop is a framework where these are pretty good. High big HBase pretty good, but you need data into the database and the big data area Hadoop. Who will bring the data into the Hadoop? Scoop is the one that brings data into the Hadoop. Imagine you have old database, like you have mainframe system, you have Oracle system, you have SQL system, and many such systems you have. You want to collate them and convert them into big data. Scoop is the one you can import data into the Hadoop or you can export data from the Hadoop. It's pretty good framework and pretty easy. And all these frameworks, you find a commonality there. It is abstraction on top of Hadoop. So you don't need higher learning time here. But most of them are one way or other are familiar to you in some sense. So much of your skills, what you had in your earlier background, you can leverage them in these frameworks. That is the reason these 4 frameworks have become very popular. And other things like Apache Flume and Hue, people wanted to have a UI for the Hadoop or for most of system. They're saying that we can't work with the black skins anymore. We want to have enriched UI. So there is a UI out there it's a common UI. The same UI works for high, big, HBase and Scoop, everything. Common UI. And how about data? Because you're saying big data has a wider scope. I don't have RDBMS system with me. All that I have is the web server logs, censored data, or incomplete, or some missing data with me. Can we import data into Hadoop and do some processing? We can. Flume is a framework where you can do that kind of unstructured data at real time. Means as and when the data being produced, you can pull data into the Hadoop. Flume is a much bigger framework. It is meant for real-time data ingestion into Hadoop. So these are the ones we'll discuss it in our class. And each one, and again, what I would be, so this is good for learning, but practically what you see in the industry, they don't work in silos. They work in conjunction. That's what we're calling as Hadoop ecosystem here. So often Hive integrates with HBase, Pig integrates with HBase, Scoop integrates with HBase, Scoop integrates with Hive. So each one has a handshake here. So I'll be taking you classes around it, and I'll be running through there is some working sessions about integrations part. This is what you are asked to do if you are looking for Hadoop job, Hadoop based job. You are expected to do these kind of things. Otherwise, if you learn in silos, very soon you'll be puzzled with the kind of workload you will have in the organizations. So you must have to understand how you have to integrate Hive with HBase and what kind of use case you can work with that. Similarly Pig, similarly Scoop. So these 4 are very crucial things for your learning curve, for your learning. So I'll be discussing about dedicated 3 days classes and some working sessions around the integrations part. And finally, so that comprises the one aspect of the Hadoop. But now Hadoop also moved on. Hadoop moved into new version called Yarn, and it has a very good Hadoop became quite old. So there are a lot of gaps people found and wanted to spread the Hadoop scope to much higher problems and higher enriched use cases. So Hadoop 2.0 is ensuring much of the needed use cases are being addressed. So these are the ones we'll discuss about the dedicated today session for Hadoop 2.0. So in the Hortonworks VM, both Hadoop 1.0 2.0 are built into it. So once you cross the 2.0, you realize that always you'll have a choice to choose either 2.0 or 1.0 framework to run the Hadoop programs. Okay.
Madhu, how can we know which version we are using in?
Yeah, you can see that there are commands. The commands are different for the Hadoop 2.0 and Hadoop 1.0, and there is some slight change in the way you execute the programs. So that is the differentiator. So Hadoop doesn't actually assume anything. You have to tell Hadoop that what you want. So if you run a certain command, it takes as a Hadoop 2.0 command. If you run certain commands, it takes as Hadoop 1.0 command. So the reason they're supporting both is that for the backward compatibility. Maybe in the coming days, in next 2-3 years, the 1.0 will be completely eradicated. Only you see Hadoop 2.0 based systems. So that is essential for your learning in this learning. In second. Okay. So this is not a very big thing basically. Running a Hadoop 1.0, 2.0 not a big differentiator there. There are some predefined commands are there out there. But the essence is that you should understand when to use what. Maybe production system would be running in 1.0 because organization would put up a lot of investments in it. But the non-staged environments or the development environments in Hadoop would be running 2.0. But when you develop a program in 2.0 and wanted to run 1.0, what precautions you should take it? And eventually, maybe in production environments after 1 or 2 years, when the investments are met, they would move to 2.0. That time your old code would run as easily like that. So this is most of practical usage rather than theory part. Theory part we will cover it, but why you need to learn these things is that this is the order of the day. Sooner or later you are asked to work on 2.0, and there will be some 1 year long migration process you will have to face in the organizations, because as you know, production migration on used datasets is not easy. It takes in stage wise, so you have to deal with this kind of migrations. And this I am not going to cover. I wanted to show you administration is there, but in the sandbox you don't see much scope for administration because everything is set up here. You are not building a system from the scratch. So this I am not going to cover because by this time we would have taken 22 classes here till the part 5. So this I am not covering, but if you need a flavor of it, maybe I'll discuss at a theoretical level for a day, for a session. So that is about the course content. If you want to see how would be the course and what how we run the course and what we teach. So just to give some brief, this was the slide of around 5 years old, where Hadoop was addressing much of the landscape, much of the use case issues. Basic beneath is the Hadoop framework. We have Hadoop CHDF file system, Peak, Hive, and many other things. But basically, they are all from Hadoop. But on top of it, there is infrastructure providers called the vendors. They provide infrastructure for the Hadoop, and you see the various frameworks working on top of Hadoop for various use cases. Some for NoSQL paradigm, some for Hadoop related activities, some for, the, let me zoom it a little bit, see, some for analytics background, some for visualizations, reporting part of it, some for statistical computing, where you purely wanted to revolutionary the one that pioneered the statistical computation on the Hadoop. And some are exclusively developed for social media data processing, like data media is the one. And some are for the, the graph theory based applications, you see it here. And some for the IT analytics, means IT are a special category where the organization wanted to process the system logs or the system generated events. They're not for the generalized purpose, so like that. So you see the many things are evolved on the Hadoop platform. This is the old slide, but if you look at the current slide, sorry, I did confuse you. This is the old slide. You see various categories have emerged from the Hadoop platform. Log data processing, IT analytics, the media means the ad media, not the media what we talked, like the content processing, basically the binary video audio files processing, like that. And BA is there, visualization is there. So many areas have emerged from it. But now this is the scope, pretty messy, and I mean to say crowded, Many subcategories have came into existence, and they're categorizing specific area of demand. So this will give an insight that, Hadoop has gained popularity and it is going to stay for a long time, because, once the ecosystem will starts, it will never ends. Even there are always a possibility that it go bigger and bigger. At some point, it might cannibalize the other system, but it will not be going to die. So this is what you see in the Hadoop systems, and more people, more and more organizations, they are jumping onto Hadoop bandwagon, and they're producing product around it, or they're producing services around Hadoop. Right. If you look at the investments wide, this is around a 2 years old slide, but again, this will give an idea that every major domain, we talked about IT industry, they are now invested in Hadoop. So yeah, if you are somebody looking at Hadoop 4 years back, many are skeptical about it, especially the healthcare industry was skeptical, and the retail industry was skeptical about it. They are concerned about the security and the transparency in systems. But now many things, insurance also, they are also very skeptical about the security, the policies around it. Even the government also. So even the Hadoop went into like FDI, the very government organizations in the US also, they have adapted Hadoop now. So that means that Hadoop passed the initial, the testimonial phase, so got into the mainstream offerings. So why organizations are really interested in the Hadoop? What that value they see in Hadoop? The value they see, so if any organization, when it's maturing it, initially they may start with reporting. So what has happened, like this is like a MIS thing. Management Information Systems will do this job, reporting of what happened. And then if they mature, the second level is that analysis. Why did it happen? The reason, they want to investigate the reasons behind it, cause analysis like that. And then they want to put as a monitoring of the real-time sense. What is happening now? So earlier these are maturity models in any organizations. And the highest maturity currently is the prediction, what could happen. So in each of the areas we have many tools. So in reporting we have the querying tools, OLAP tools for the analysis part, why it has happened, and then monitoring we will have dashboard technologies, and for predictive models we have for the predictions. So the higher the any technology which is offering all or the higher things, that gives more value to the organizations in terms of the business value, in terms of ROI point of view, in terms of cost of ownership point of view. So Hadoop is the one that is offering in all the areas. You can play at any level of maturity model, still be at a low cost, means the higher value to the organization. This is one of the reason why organizations are pretty much interested in the Hadoop. Apart from being compliant with security, being compliant with industry regulations, these are the actual area which is the reason it's becoming popular. Okay, so that is with the I didn't discuss the brief so far. I just jumped onto the certain slides, so that will excite you. And this is one of the use case for the Hadoop and popular use case. The first use case, this is a broad use case. Under this, you have thousands of subcategories here. So each data source will become a candidate for hundreds of use cases here. Each one like this. Even this also becomes hundreds of use cases will emerge from this thing. So this is a broader classification of the higher level of the problem area, and it's going to solve. So if you look at it, enterprise warehousing is there for a while. It has been stabilized and been standardized. It is doing a wonderful job in this area, where organization can pull up the data into some platform, and then they can transform to the level of their business model, and then they can build report on top of it, or build OLAP cubes on top of it, or they can build monitoring systems on top of the enterprise warehousing thing, right? Or they can even expose the data to other B2B partners or B2C partners. But whereas, so the limitation of warehousing comes when you have to deal with wide variety of data sources. I mean to say, when the data falls to the level of semi-structuredness and the no structure, then the trouble starts in the data warehousing. The amount of effort and investment you have to put increases multifolds in the warehousing thing. That's where Hadoop will come to rescue. So Hadoop, rather than a competitor, it is more of collaborator in the existing technologies. So what it is primarily doing nowadays is that it is taking up the challenging part in the industry, taking up the challenge, taking up like areas like non-structured data, semi-structured data, and then transforming it to a level where it can be consumed by the existing investments. So they don't have to provide a new framework to parse the new data here. So much of the complexity are handled in the Hadoop with that volume also. I mean to say, if you have to address a volume around hundreds of terabytes in a month, this system will collapse. But in 100 terabytes, you only need certain fraction there. You don't need much of the data. So what essentially you have to do, you have to take the data, process it, then transform it, and then finally extract the essence of the data and send it to the warehousing thing. That's exactly the Hadoop is going to fit in with very cost-effective model. You know, traditionally one comparison is that for a GB in a warehousing thing or database, one has to spend $25. Whereas in Hadoop, for a GB, I'm talking about high level, at a higher average value, may not be applicable for everything, but just to give a sense, for a GB, Hadoop takes $1. So 1 by 25th cost reduction straight away. So why not organization executives will take this technology, since they have a huge cost advantage with comes with compliance support and regulatory support. So that's where Hadoop is winning the game. So in some cases, Hadoop is like a outbeater of the existing technologies, but in most of the cases, Hadoop is like complementary with existing technologies. So it could be a warehousing thing, or it could be your simple database repositories, or it could be your simple file system based content thing. Like say if you're using SharePoint, you don't be using any database for it, maybe for a management, but actual data is on file system only. So in that case of systems, how do you become a complementary? So that sense. So this area of repository could be anything, like your traditional systems or a new system like that, right? So this is one area. So what are the basic things in Hadoop? So why industry is so it's Hadoop is the only system that is able to do or in any system. So the reason is that now we have had 3 dimensions in the data. Earlier we used to only have the data volumes only. When you are commissioning the Oracle system, always you are talking about how much data size. Is it 10 GB or 10 TB like that? That is the only dimension you used to take in the estimations. Very rarely you are considering about data increase, means data velocity part of it. How at what speed data is going to increase. Because you know that hardly in a year you may not be accumulating more than 1 terabyte. So you actually plan for 10 terabytes well in advance, may not be having at this time. But that's what your expectations at the end of my year or 2 years, I would have 10 terabytes. So the reason is that you do upfront investments for that sizing. So basically most of the estimation would be circling around volumes only. But now with the advent of many repositories, I mean to say, many unstructured data and semi-structured data, the variety and velocity have increased. So you have to consider at what velocity and what variety your data is going to grow. If that is in this 3-dimensional data model, it is hard to manage a existing system with these use cases. So you should have a system that can elastically expandable to the growing volumes and the velocities, and yet should be able to take up the variety of data sources. So Hadoop is the only popular system that can suffice the 3 dimensions in the emerging world. So we'll discuss about these volumes, how they are, what they are positioned in the coming slides. I'll discuss about more what the aim is for this 3 dimensions. So coming to the brief, I'll just talk about the brief part of it. I'll running through the comparison between the RDBMS and MapReduce. So if you are not familiar, this will I'll run through some samples around it. You'll understand it better once you discuss these things. And coming to the MapReduce framework, I'll touch upon how the framework is being positioned, how it is leveraging the various sources in the Hadoop. We'll discuss that. And then, I'll discuss about the offerings in the Hadoop. Like we have Cloudera, MapR, and Hortonworks. They are the popular distributions on top of Hadoop. The distribution is like if you look at Linux is not there's no organization that produces like Linux. Means if you look at Windows, Microsoft is the only company that produces Windows. But in Linux world, there are companies, they support Linux, they don't produce Linux. If you look at Red Hat, they don't develop Linux, they support Linux. Or Ubuntu, or CentOS, they are just enablers of Linux, means they are called distributions of Linux. Similarly, Hadoop is Apache free software foundation software. No one can produce it. It is there all the time. But most of the times you need certain support flavor, you need some enriched experience on top of the native Hadoop. So the companies, they took the code base from the Apache foundation and they're offering enriched experience on top of the Hadoop. So that's the reason we call them as Hadoop distributions. So the one you're seeing now, this is a distribution on top of Hadoop. But at the core, they would be running the Apache Hadoop framework. Right. So this is about a touch upon the Hive part, and we'll see a good amount of hands-on with Hadoop, and then Pig. This is Pig. We touch upon the Pig and HBase. We touch upon HBase, and then the Hadoop 2.0, Hadoop Scoop, Hadoop UI called Hadoop U. HU means Hadoop UI. and then the Flume. We touch upon these things, and the catalog is the one that is integrated between various things. It integrates Hive, Pig, MapReduce, and any other frameworks. We can have multiple frameworks around it. It integrates with Hadoop using common framework. So we'll touch upon that. Right. So that is in nutshell. So you see in the course that 50% is 40 to 50% is the theoretical part, and the rest would be the hands-on. So in each of the trainings, what I do typically, I have two sets of models. One is that I start from I would supply the datasets also, samples and large sets. Samples will kickstart your learning, maybe small files, give you conceptual understanding about technology. But the large ones are pretty good one. They are the sizable ones. They are around 200 MB, 300 MB data size. Pretty good to work with the VM. Not that we can't take GBs of data. We can, but this VM will crash because you are running a VM in your machine, right? But if you have dedicated cluster in your office or somewhere, then I can give you a bigger data sets. But these datasets are around 200 MB or 300 MB sizes. So this will give you a fairly good experience on this dataset, on the various features in the Hadoop. And then the scripting part, the various scripts you need. So every time I'll start with the basics, and I'll start with so I'll start with the basics one, then I'll start with advanced learning, and I start with basics, then I start with advanced learning, and also I'll start with the various other flavors here. So that way, in each of the technology area, you see pick basics and pick advanced like that. So this will not be confusing you, the simple one for understanding. So once you're comfortable, then we'll start with advanced learning in the peak like that. So that way we'll structure it. But before that, I'll be sending this requisite prerequisite document so that this will help you in setting up the environments. So how to download this, how to set up this VM, what all additional tools you need to connect to this VM, because how do you connect it? So there should be connecting tools. There should be Eclipse tool to work programs against that, like that. So that is pretty much about the Hadoop. Now we can have yeah. So to coming to the Madhusudan's question, I'll just hold at this point. Yeah. So for you, let's say if you have purely mainframe background. So, but if you have SQL, did you ever work in writing queries or
yes,
yeah. So Hive is the one that is more like gives you a SQL flavor. You can write cell star from something, you can join two tables, insert data into it. All the SQL learning you can apply in Hive. So Hadoop system enable you to work with Hadoop in a SQL manner. So this will excite you. So for Pavana and Phanindra, because they are already familiar with the warehousing concepts or database concepts, so they can choose Hive and Peak, and each one is meant for a different use case. But importantly, what you should all understand is that you should be able to write MapReduce job if required. Not that you were asked from day one, let's say if you are pursuing Hadoop-based job. Most of the time you don't ask you to write MapReduce job because that's a low-level thing. It means nowadays, do you see anybody who is that count-wise are higher? Java programmers or C++ programmers? Obviously, Java programs count is much higher. The reason is that Java is an abstraction language, higher language. C++ is used only when things cannot be done in Java or .NET. They go for driver program, interface program, or developing a new framework, new file system. Then they go for low-level program like C++. So MapReduce is like C++ for Hadoop. So you'll not be asked to write programs in MapReduce, but you should be aware of what has to be done in MapReduce. Right. So before we actually come to this level, I will be talking about MapReduce coding. So you'll be setting up Eclipse like that. So for Pavana and Fanindra, these things will excite you further because you see much more enriched flavors in this. For Madhusudan, I don't see big challenge for you because you'll not be learning entire new set of things. Your existing learning or familiarity, you can apply it here, right? And you see new things like Scoop, you would not have seen it before. And there's no learning curve for it. Scoop is mostly a high-level abstraction on top of Hive and Pig. So all that is commands only. Whereas Hive and Pig has some programming language. HBase has a programming language, but Scoop doesn't have. It's just a set of commands. Similarly, Flume, it is just a set of commands. Similarly, Apache Hue, it is just a set of commands like that. So we are covering almost 7 new things in the span of 20 or 22 classes. So typically, we would be covering, spending around 3 days or 4 days, depending on your comfortness. I would be spending like that per technology. These are all multiple technologies. Each one is for a certain use case, but they all connect each other.